What's up? What is happening? This is Mr. Ayers back for lesson 3. I'm bringing it to you live. We are talking about addition and subtraction word problems. Alright, so open up those knowledge tanks. I'm going to fill it up with some mathematical gasoline. So, here's your objective: to write and solve equations from word problems. And today we're looking at specifically addition and subtraction ones. Next lesson, lesson 4, we'll look at multiply and divide. Okay, so let's go to our fun day. Our fun fact of the day is that lizards can self-amputate their tails for protection, and it will grow back after a few months. So here's a lizard who decided to cut off his tail. Maybe they did that because, some animal was chasing it, had a hold of it, and they were able to detach it and run away, which is pretty awesome. Okay, so let's go ahead and get into some of the math examples. So here we are with example 1. It says, in the first half of the game, Heidi scored 12 points. In the whole game, she scored 27 points. How many points did she score in the second half? Now, you may be looking at this going, duh, Mr. Ayers, she scored 15 points. It's pretty easy. I'm going to take 27 minus 12. And hypothetically, yes, but the whole process of this is to learn how to write equations. Okay, so how to put in a letter and how to solve for it. So this is an important skill here. Okay, so first thing I like to do is underline the stuff I know. I know in the first half of the game, she scored 12 points. In the whole game, she scored 27 points. And then I want to know how many points in the second half. Well, if you know anything about a basketball game is an addition problem. Okay? I'll say it again. A basketball game is an addition problem. Why? Well, because we always play the first half. And whatever points are scored in the first half, we always add those points to the second half points. And the first half points plus the second half points always equals the total points. And it doesn't matter if that's for a player or a team. Okay, if a player scores 2 points in the first half and 3 points in the second half, they get 5 points. If a team scores 50 points in the first half and 40 points in the second half, we add those, they get 90. That's how basketball games and sports in general works. Okay, so now I'm going to fill in. I know the first half of the game, Heidi scored 12 points. And we have to add that to her second half points. Well, if I look here, it says how many did she score in the second half. So I have no idea how many points she scored in that half. So I'm going to put a variable, a letter. I'm going to pick P for points. And that's got to equal her total, where her total points is 27. Now I'm looking, and I know we just spent a couple units on solving equations like these. So you should be able to look at this, go, okay, we're taking P and adding 12 to it, so I got to get rid of that with a negative 12. I'm going to switch to my red pen for this work just because. And that's going to cancel, and I'm going to have P equals 15. And look at what we did here. We took 27 minus 12, which is what I said at the beginning of the slide that most of you would probably want to do. But here's how the equation setup goes. We're starting with an amount, we're adding some more in, we're having a first half points, and we're adding in a second half points to get to the total, the whole game. So this part right here, the equation writing, is extremely important. Okay? So, if I'm going to answer the question, I'm going to make sure I go ahead and say the answer is she scored 15 points. Gotta have the label. Alright, and let's go ahead and we just have one more example of these. Alright, so now we got a story about Alberto. Alberto went to the store with a $20 bill. He bought a loaf of bread and a half gallon of milk. The clerk gave him $15.17 in change. How much money did Alberto spend on bread and milk? And explain why our answer is reasonable. Okay, well this is a case where I know at the start of my story here that Alfred went to the store with a $20 bill. Okay? Then, after that, he spent some money, right? He bought some stuff, which means he's taking money away from this $20 that he has. And then once he did that, the clerk gave him some money back. Okay? So let's stop and think about this here. We know that Alberto, started with some money. Then he spent it, which means he's taking money away, okay, for his food. So here's his starting money that he walked to the store with. He's taken away the money he spent on food, and we know that's going to equal how much he gets back, and that's called the change, right? Okay, so Alberto went to the store with a $20 bill. Okay, he's going to subtract some amount of money. Isn't that what we're trying to figure out, is how much money he spent on bread and milk? So I'm going to put, oh, I don't know, an M for money. And that's got to equal his $15.17 in change. Okay? Well, I'm going to go ahead and solve this now. I'm looking, going, okay, here's my M term, my letter term. So I'm going to take away the 20 from both sides. Okay, so look at this. I got negative M. That's the same as negative 1M. These are different signs. So I'm going to subtract. I'm going to take 20 minus 1517. Okay, and that is 4.83. And there's more negatives than positives, so it's negative. Now again, this is why I like to put the negative 1M here, okay? Because now I'm seeing that if this is a 1M, that I've got a number attached to the letter, so I'm going to go ahead and divide by negative 1 on both sides, since I can't have a negative amount of money, right? So those cancel, and I get M equals, negative by negative is positive, that's $4.83. Okay? We're also asked right here to explain why our answer is reasonable. So my answer is $4.83. And it is reasonable. Actually, I'm going to erase that. Let's go ahead and put that down here. We got some room. Okay? $4.83. And that is reasonable. Well, why is $4.83 reasonable? Let's pretend for a second that Alfred went with $20 and somehow for my answer I got that he spent $24. That's not even possible, is it? He can't spend more money than he has. So I'm just going to say it's reasonable because he spent less money than he started with. And I think that's a good enough than he started with. I think that's a good enough reasonable explanation. Like I said, if we would have gotten $24 or something for our answer, or $24.83, then something would be kind of fishy, okay? Because we can't spend more money than we started with. Well, if we got any Star Wars fans out there, you'll recognize this guy. That's Yoda. He's saying, end of presentation, this is. So I'm going to conclude this lesson with my typical saying, which is happy homeworking.